So let's welcome from that overview, that brief overview. We can now talk about a nucleotide and a nucleoside. These ones, they are almost similar, just that they have actually one difference. Okay? So we have said that a nucleotide is a building block of nucleic acids. So what is that nucleotide? And if somebody from nowhere tasks you to talk about a nucleotide, what are you going to say? Because before you understand what a nucleic acid is, or what are nucleic acids, you need to first understand the building blocks, so that you use the knowledge of building blocks now to clearly understand what nucleic acids are. So nucleotides are simply building blocks of nucleic acids that do contain an organic base which contains nitrogen. In some books, they can refer to it as nitrogenous organic bases. Okay? Nitrogenous organic bases. Now, these nitrogenous organic bases, they are attached to a ribose sugar. Okay? To a ribose sugar, name me first, yes. A 5 carbon pentose sugar, not ribose. A 5 carbon or pentose sugar on carbon number 1, and then on carbon number 5 of that pentose sugar, you have there phosphoric acid or a phosphate group. Okay, guys? So it is an organic base. We are going to talk about organic bases and see what are they. Attached on a pentose sugar. Now, depending on which pentose sugar, it could be a ribose sugar, that is if it is a ribonucleic acid, RNA, or a deoxyribose sugar, that is if it is DNA, on carbon number 1. But on carbon 2, then you have there, so on carbon number 5, then you have there phosphoric acid. Then chemical linkages between monomer units are called phosphodiester body. Let's have a look at this. This is basically a nucleotide. Just this. Okay? So if I take you back to chemicals of life, we can talk about each. You have your ribose sugar. Like I told you, at each corner is a carbon atom. Okay? So you have the O, then you have carbon number 1, you have carbon number 2, you have carbon number 3, you have carbon number 4, okay? And then this one is attached to oxygen. Then you have carbon number 5 here, CH2OH. So you have the OH here, you have the H, you have the OH here for the case of a ribose sugar, then you have the H. But for the deoxyribose sugar, this is simply H. Then you have the OH, then you have the H, and finally you have the H. So this is our ribose sugar, if you remember from chemicals of life. Now, with phosphoric acid, it is simply H3, P, phosphate, and O4. And if you are to draw its structure, it is simply a phosphate group, then with one oxygen atom, the rest are OH groups. Okay, the rest are OH groups. OH groups. So this is our phosphoric acid. Then with a nitrogenous base, let's just simply draw some simple structure and maybe put NH2 here. So now there are these groups that are going to condense together, okay, by condensation reaction to form an overall structure of a nucleotide. Whereby you can have a look. The OH group on phosphoric acid is going to condense with the OH group on carbon number 5. Are you seeing that? And you form that phosphodiester bond. Yeah, you form this bond here. Then the OH group on carbon number 1 is going to condense with one of hydrogen or nitrogen to form this bond, which is going to link a nitrogenous base with a pentose sugar. So the overall is going to form a nucleotide. Also, guys, that's brilliant. Now, since we have said that these nucleotides are building blocks of nucleic acids, then when these nucleotides are linked together, okay, you get this nucleotide, you can have a look, okay, you link it with another nucleotide. Are you seeing? Where this is a phosphate group, this is a ribose sugar, and this is the organic base. You are going to see them. This is a phosphate group, this is a ribose sugar, and this is an organic base. Phosphate group, ribose sugar, and organic base. Phosphate group. So do you see that it is just a repetitive unit of the same and organic base? So now, if these nucleotides now condense together, are you seeing that it is this phosphate group that is now joining this nucleotide and this? Are you seeing that it is this group that is joining this nucleotide and this? Are you seeing that this group? So if the phosphate group, if the OH on the phosphate group condenses with the OH, okay, on the pentose sugar, and you lose water, obviously, then the bond that remains, a phosphodiester bond that remains, is the one that will bind this nucleotide to this nucleotide. And if further condensation occurs, now this one I've just circled because we did that, but it is condensation where the one H takes away the H and you remain with the O. Okay? The O. So that's why I just did this. So when further condensation occurs, then you can add these nucleotides together. Okay? You can add these nucleotides together and form what we call a nucleic acid, which is either DNA or RNA. So this is our nucleic acid. Okay? And these are our nucleotides. Not so, guys? Yes. Now, a nucleotide without an organic base is referred to as a nucleoside. Without this organic base, if we get this nucleotide and we take away the organic base, then it becomes a nucleoside. So basically, that's how simple it is. In case there are questions, feel free to hit the chat box. I'll be glad to attend to your questions.